Good morning, everyone. Algebra 1 students. Today's lesson is going to tackle one of my favorite topics, rate of change or slope. So the title of this lesson would be rate of change, which we've been talking about actually here and there over the last several days, also known as slope of a line. And before we get into the lesson, I want to do this little warm-up. You can see I drew an x-axis here on graph paper and a y-axis, and I locked in 2 points that I made in red. And I just want to kind of pose the question, what would be one way to find the distance between these 2 red points? Like from here to here, how many? Most students in the past have told me, well, Miss Callahan, it's not too difficult. Just count the blocks between here and there. So let's kind of look. If I go from here to there vertically, I'm counting 1, 2, 3, 4, 5, and 6. So we're going to say that this distance right here is 6 units long. Pretty simple. But I want to show you an alternative way to think about this, and we're going to need to do this in just a few minutes when we derive the formula for slope. I want you to think of it as, what if we had found the distance from the x-axis all the way up to the top point? So let's count that distance first. So x-axis to the top point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this whole distance here, 10 units. Okay? And then, what if we counted from the x-axis to the bottom point? Okay, so from the x-axis to the bottom point, we've got 1, 2, 3, 4. Okay, so we've got a 10 to the top point, 4 to the bottom point. Now, what could we do with those 2 numbers to get 6? Hopefully you're thinking subtract them. So if I take 10 and subtract 4, I get the red distance. And that's because if you take this whole distance minus this distance, you'll have, let me change to red here, you'll have what's left over. So the whole distance minus the little distance gives you what's left over. So I want you to keep that in mind because we're going to need that in a few minutes. Now we can also do a horizontal distance, kind of thinking along the same lines. So let me look at this point up here against maybe this point right here to the right. Okay? So obviously the easiest way to find the distance between these 2 points is to just count. So let's count the distance. So if I count from here to here, I'm going 1, 2, 3, 4, 5. Oh, I got another 6. I didn't do that on purpose, but we'll go with it. So that distance is 6. Okay? Now here's another way to think about this. If we measure from the y-axis now, okay, so let me go from here to here. Okay, so come up here, here to here. If I count the full distance from the y-axis to the farthest point, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 this time. So this distance right here is 11. Okay, now let's count from the y-axis to the first point here. What's that distance? Okay, let's count. 1, 2, 3, 4, 5. So this is a 5. So if you think about the 11 and the 5 and the 6, you can see that 11 minus 5 equals 6. So that's another way to get it, because if you take the whole distance minus the smaller distance, you're going to have what's left. So the whole minus the little equals what's left. Okay, so pretty simple concept, but it's going to be really helpful in just a minute when we switch over to our notes page, which is blue. So you want to grab your notes page, deriving slope formula. Listen, what you guys don't wholly know about me yet is that I'm a big Y person. So I could totally just come right down here to the bottom of this page and we could just do the formula. Like I can give you the formula right now. In fact, let me do it. I'm not afraid. Look at what it says down here. It says, to find the slope of the line passing through 2 points, an X and a Y, and another X and a Y. And the only way we can decipher that these 2 points are different is that these little subscripts, these little ones, we're just going to call this the first point, X sub 1, Y sub 1. So some X and some Y, and another point. And the way that we're going to denote this one to show that it's different than the first one is to call it the second point. So X with a subscript 2. We say X sub 2, Y sub 2. Then you're going to use this formula. Now, M. Where's my highlighter? Here it is. M, you probably remember this possibly from last year. M is the letter in math that we use to represent slope or rate of change. Okay, M. So the formula for M looks like this. You take the Y sub 2 minus the Y sub 1. So you take the two Y's and you subtract them. And then you put a division bar and you divide by the X sub 2 minus the X sub 1. Now, I can tell you now, the reason for division, the divided by sign really means per. And we know that slope is a rate. So we have to have a fraction. We have to figure out how quickly Y is changing and divide it by how quickly X is changing. That's why we divide. And we talked about that a little in the previous days. How quickly Y is changing divided by how quickly X is changing is going to give us things like miles per hour. So how quickly is your distance changing divided by how quickly your time is changing is a rate of change. It could be gallons per minute. Maybe you're filling up a bathtub and you want to know how quickly that's happening. So how many gallons are going into the tub every minute? That's a rate of change. So that's why we have the division. Okay? But why do we subtract these two and why do we subtract that two? Why is that going to give us the rate? So I want to show you why. So this is what. Now we're going to get into why. So let's go back up to the top. We're going to read this little paragraph. It says, every line has a unique slope or rate of change. To find this slope, we can locate 2 points on the line and then calculate the change in Y between those 2 points divided by the change in X between those 2 points. This will give us the overall rate of change of Y with respect to X. So just using the example down here, I mean, say that the Y-axis on this graph I gave you, say that represents distance, say that represents miles, okay? And say that the X-axis is time. Let's say that this represents your hours. Well, by taking 2 points, right, on the graph and finding not the distance between them, but the change in the Y's between them per the change in the X's between them, okay, then you've got yourself this. Okay, how quickly is the Y changing minus over how quickly the X is changing? Check it out. Okay, now, like in this example, one way to do it is to count the rise. We call this the rise, the vertical change. Call that the rise. You might remember that from last year. And we call the horizontal change the run. That's sort of our informal wording, the rise divided by the run. But we can also find this distance by taking let me change colors here for you. We can take the entire distance from the x-axis to the top. Okay, so from the x-axis, measure up to here. And we can subtract this inner distance from here to here. So if we take this guy minus this guy, we'll have the distance in between, right? Okay, so let's give these purple dots, let's give them some ordered pairs. So let's just say, doesn't this point look like it's at like 1, 1? So let's call this 1, 1. Okay? And then this guy stretches out further and comes up higher. So let's call this guy, now we can't tell really, we're just going to make something up because I don't know how many points are in between here, but it almost looks like if this is 1, maybe 2, 3. So why don't we call this guy 4, and 1, 2, 3, 4, call him 5. So we'll say this is at 4 and this is at 5. So let's call this 4, 5. Okay, so now let's get this distance. So the full distance from the x-axis to this point here is 5 units. So we'll take the 5. And the distance from the x-axis to here, right, is just 1 because that y value is 1. So 5 minus 1 is going to give me 4. And that is, let's count here. So if I'm here and I'm going to here, 1, 2, 3. Oh, did I mess up here? 1, 2, 3, 4, 5, 6. I did mess up there. This should be a 6. Thought something was wrong there. Let's change that to a 6. So instead of making this a 5, this is a 6. Pardon my mistake there. So now if I take 6 minus 1, cross him out, I get 5. And now you can see from here to here, from the rise, in other words, from here to here is 1, 2, 3, 4, 5. That's much better. Okay. Now, that's my rise. Now, I know that's my change in y. This is my change in y. This little triangle here that I just wrote, that's called delta. It's a Greek letter that means change in y. So y has changed by 5 units. Now, I'm going to divide per the change in x. So now I've got to go from the y-axis, measure out to this point, and that is 4 units, from here to here, 4 units. And then I'm going to subtract the distance from here to here, which is just 1 unit. So the whole thing was 4. The inner is 1. So 4 minus 1 is 3. So let me double check that. If I count from point to point, 1, 2, 3. Yeah. So here's my slope. Here's my rate of change. Now let's check it out. So for every 5 on the y, 1, 2, 3, 4, 5, I go 3 on the x. 1, 2, 3. Yeah. Okay. So notice what I did here. Now look at this formula down here. Notice what I did. I took the 6, which was a y value, and I subtracted this 1, which was another y value. So I took a y value minus another y value, a y value minus another y value, and I divided by an x value over another x value. So I took a y minus a y divided by an x minus an x, and which one's which? Well, I always call the point on my left side, I give those the 1s, that's my first point, and my point out here on the right are my 2s. So I took y sub 2 minus y sub 1 and divided by x sub 2 minus x sub 1. Interesting. Okay, so by the way, for every 5, 3, so maybe we go 5 miles in 3 hours. That would be pretty slow. 5 miles in 3 hours. Whew, we must be crawling or something. Or maybe we do fill up the bathtub 5 gallons every 3 minutes. This is some rate of change. Okay, so generally speaking, this is the last part of this. Generally speaking, what I want you to do with this graph is this. I want you to take these 2 points, okay? Mark them down. And I want you to give them generic coordinates. So we're going to call this first guy x1, x sub 1, comma, y sub 1. We don't know where it is. We could be anywhere. This is going to work for any graph. X and y, and it's the first set. Likewise, we're going to give our second set x sub 2, y sub 2. It's also an x and a y, but it is the second pairing. All right? So from what we've done today so far, we know that the change in y, we find it by taking y sub 2 minus y sub 1. And again, you're taking tall minus short. This is your y sub 2. This is your y sub 1. You subtract the 2 to get this distance. Y sub 2 minus y sub 1. Boom. Tall. This is a y value. From here to here is a y. From here to here is a y. You take this y minus this y, and you get the distance that's left over. Okay? To get your horizontal change or your change in x, same idea. You're going to take big X. So from measuring from the y-axis all the way out, that is this guy. This is an x value. This is x sub 2. And you're going to subtract this distance. So from here to here is this x value, x sub 1. And the leftover right here is the difference between them, x sub 2 minus x sub 1. And so we come to this where we started. The slope or rate of change of a line is the quotient of the change in y over the change in x. So that is the reason this formula is what it is. Okay, so let's practice some. So let's take a look at your slope examples here. Couple slope examples. So we start off with 5 graphs, and we're just finding the slope. So find the slope. So we need the change in y over the change in x. Now, what's great about graphs is that we can just count. Lovely. So here's what I want you to do on number 1. Highlight the 2 points that they've given you. There's a bug on my desk. Where'd you come from? Okay, so highlight these 2 points, and we're going to count from left to right. I always go left to right, left to right. To move from this point to this point on the y, we're going to have to drop down to here. And then we're going to have to move horizontally to get over to the other point. So this is my change in y, and this is my change in x. Okay, so let's count the change in y. We've got 1, 2, 3. So we've got a change of 3, but we're going down 3, so I'm going to assign a negative to it. So I go 3 down, and then I go 1, 2, 3, 4, 5 to the right. And so my answer to this problem, my rate of change is I move down 3 units and to the right 5 units. Okay? Take a look at number 2. Highlight the 2 points, 1 and 2. Always moving left to right. So I'm going to start here. To get from here to here vertically, I have to go down, and then I'll have to move right. So now I count. I moved down 1, 2, 3, so negative. So down 3, and I moved to the right 1, 2, 3, 4. Therefore, my rate of change, m, is down 3 on the y for every 4 on the x. Okay, it's pretty easy. Take a look at number 3. Highlight your 2 points. Moving left to right. Now this line is coming upward, so to get from point to point vertically, I have to cruise up the y-axis and then right on the x. So I have to count 1, 2, 3, 4, 5, 6, 7. And on the x, I just move 1. So my rate of change is 7 y's for every 1 x. And 7 over 1 is 7, so you could write it like that as well. Number 4, 2 dots, okay. Left to right, cruising down the y and right on the x. If I count that, I've got 1, 2, 3, 4, 5, 6, 7. So I'm coming down 7 and 1, 2, 3, 4, 5, 6 and right 6. So my rate of change is down 7 on the y for every 6 on the x. And last but not least, boy, I got a lot of negative slopes here. The last line here, left to right, I'm coming down and right. So counting 1, 2, 3, 4, 5, 6. So down 6 and boom, 1 to the right. So down 6 per every 1, which if you divide is just -6. So that's pretty simple. That's just counting. You can, when you're given a graph, man, that's the best because you can just count your rise over your run or your change in y over your change in x. Here's where the formula is going to come more into play. What if they don't give you a graph? What if they just give you the 2 points on your graph? Now, this is like they're giving you these, okay, so like this one, they're giving you these 2 points. They're just not giving you a picture of it, so counting is not an option. So this is where you have to use this formula. Okay? So let's do it. First, you're going to label your points. You ready? This is an x. This is a y. This is an x. This is a y. We'll call this guy the first set. We'll call this guy the second set. And the rest is history. Slope equals. Now, one thing I like to do is I like to put my division bar because I know it's per. And I also know that in my formula, I have a minus here and a minus here. This will never change. What will change are the numbers that go in these 4 spots, because these 4 numbers that you're going to plug in depend on what these values are here in your coordinate pairs. So we know that the first one here is your y sub 2. So you have to look up here. You see that y sub 2 is 14. So I'm going to put 14 in there. And then in this slot, I'm going to put y sub 1. That's -6. X sub 2 goes here. X sub 2 is 16. And this is x sub 1, so that's -18. Lots of negatives here. That's why I like the parentheses, because you got to be careful. Now we simplify. So 14 minus -6 is 20. 16 minus -18 is 34. So we reduce this. 2 goes into both 20 and 34. 2 goes into 20 10 times. So I'm taking this divided by 2. And 34 divided by 2 is 17. So let's call our final slope 10/17. Okay, and we have 2 more. So number 7, we have 2 ordered pairs. So we've got an x and a y, an x and a y, and we've got our first set, and we've got our second set, and we've got m equals, I'm going to draw my division bar with a minus here, and 4 different sets of parentheses for my numbers to slide in. And so my formula goes y2, that's 4, minus y1, that's 8. x2, negative 13. x1, 5. And now we reduce. So 4 minus 8, that's negative 4. Negative 13 minus 5 is negative 18. Now we know a negative divided by a negative is a positive, and both of these are also divisible by 2. So let's divide them each by 2. So negative 4, or I'm sorry, we already took care of the fact that the negative over the negative is a positive. So I'll just do 4 divided by 2 is 2. 18 divided by 2 is 9. Final answer, 2 over 9. And our last one. Okay. X, Y, X, Y. First set, second set. Okay. M equals fraction bar minus minus. Okay, here we go. Y2, negative 17. Y1, boom, negative 11. X sub 2, negative 17. X sub 1, negative 1. So, negative 17 minus negative 11 is negative 6. Negative 17 minus negative 1 is negative 16. Again, a negative divided by a negative is a positive, so I'll just reduce by dividing by 2. That's the biggest number that goes into both of these. So that's just going to be 3 over 8, final answer. All right, so just to recap and put some kind of final word on this, we started with this, just counting and how to get distances a different way. We derived the formula for slope. So all of this is for my y people. Like, where'd that come from? This is where it comes from. And then we used it to find slope, whether it was counting rise over run or using the formula that we derived. So thanks for watching. We'll see you next time.